Excavation safety. Excavations are defined to include trenches. The definition of an excavation is a man-made cut or cavity, including open face excavations. Let's begin. Competent persons. Competent persons mean one who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take the prompt corrective measures to eliminate them. Protective system means a method of protecting employees from cave-ins, from material that could fall or roll from an excavation phase or into the excavation, or from the collapse of adjacent structures. Protective systems include the support system, sloping, benching system, shield system, and other system that provides the necessary protection. Support system means a structure such as underpinning, bracing, or shoring which provides support to an adjacent structure, underground installation, or the sides of an excavation. Trench. Trench excavation means a narrow excavation in relation to its length made below the surface of the ground. In general, the depth is greater than the width, but the width of the trench measured at the bottom is not greater than 15 feet. Excavation work is one of the most hazardous types of work done in the construction industry. Injuries from excavation work tend to be very serious nature and often result in fatalities. The concern in excavation related activities work is a cave-in. Cave-ins are much more likely to be fatal to the employees involved other than construction related accidents. Furthermore, a high rate of injuries has continued to occur in and around excavations. Although the concern in excavation related work is in this video we will also cover other dangers may do not often think of, including hazardous atmospheres, underground utilities, and vehicle mobile equipment exposure. Trench is an excavation, but it's narrow and not more than 15 feet wide at the bottom. If forms or other structures are installed in an excavation that reduces its width to less than 15 feet measured at the bottom, the excavation is also considered a trench. Examples are shown in the pictures. One of the most important steps in avoiding cave-ins in the pre-planning of excavation operations. Some of the questions that must be answered prior to digging are: what types of soil will be found? What are the soil moisture conditions? Has the soil previously been disturbed? How large will the excavation be? How long will the excavation be open? What kinds of weather can we be expect? What kinds of equipment will be on the job? Will the excavation be near structures? Is traffic control needed near excavations? What source of vibration will be nearby? Will water be a problem? What kind of shoring? How much? Underground installations, if there are any underground installations. Access underground installations. The picture is shown as an example. Determine the estimated location, contact the utility or owner, proceed cautiously, find the exact location, support, protect, or appropriately remove the installation in open excavations. Surface encumbrance, remove or support if creating a hazard to worker. What are some examples of surface encumbrances? Poles, rocks, trees. Next is access egress. Structural ramps used for access or egress of equipment must be designed by a competent person qualified in structural design. A safe means of entering and leaving excavation must be provided for workers. A stairway, ladder, ramp, or other of egress must be located in trench excavations 4 feet or more in depth and require no more than 15 feet of lateral travel. Underground installations. Don't forget to support utilities that transverse across the excavations, which can possibly lead to collapse. Remember, surface markers may have been moved to accommodate moving. They may have also been vandalized or altered. Surface encumbrances, stuff that can fall into the trench, sign, post, trees, boulders, pavements. Access and egress. In addition to the 4-foot depth and 25 feet lateral requirements, don't forget safe means, for example, ladders, stairways, etc. in good condition. No former extension ladders stable, no impalement hazards. Exposure to vehicular traffic. Employees must be provided and wear warning vest or other suitable garments marked with or made of reflectorized or high visibility materials. High visibility apparel must allow you to contrast from all surroundings. This is performance based rule, meaning you perform to it. The color of your vest shirt depends on the color around you. Retro reflective material must be worn when natural illumination is insufficient. For example, dawn, dusk, fog, stormy, etc. In addition to the garments, is there a need for traffic control? For example, signage, channeling devices, etc. Exposure to falling loads. Employees are not allowed under loads handled by lifting or digging equipments. Workers must either stand away or otherwise be protected from any vehicle being loaded or unloaded to avoid spilling or falling materials. Warning system for mobile equipment. A warning system must be utilized when mobile equipment is operated adjacent to an excavation or when such equipment is required to approach the edge of an excavation and the operator does not have clear and direct view of the edge. Barricades, hands, or mechanical signals or stop logs can be used. Next is hazardous atmospheres. Purpose: prevent exposure to harmful level of air contaminants such as oxygen deficiency, explosives, flammables, toxins, and to assure acceptable atmosphere condition through atmospheric testing, removal of substance, proper ventilation, respiratory protection, etc. Testing and controls. Testing is required where oxygen deficiency less than 19.5% or hazardous atmosphere exists or could reasonably be expected to exist. Example includes excavation in landfill areas or in locations where hazardous substances exist, that is utilities, tanks, contaminated soil, etc. When controls such as ventilations are used to reduce the level of atmospheric contaminants to an acceptable level, testing must be conducted as often as necessary to ensure continue, continuing safety. Emergency rescue equipments. Emergency rescue equipments must be readily available where hazardous atmosphere conditions exist or can reasonably be expected to develop. Note: Division 3 subdivisions D, A, and E provide additional requirements. Additionally, worker entering bell-bottom pier or other similar deep and confined footing excavation must utilize a harness or lifeline system. Trenches or confined spaces, check for oxygen deficiency, explosives, flammables, toxins, and to ensure acceptable atmospheric condition through atmospheric testing, removal of the substance, proper ventilation, respiratory protection. Testing and controls. Atmospheric testing is required where oxygen deficiency less than 19.5% or hazardous atmosphere, flammable or toxic exists or could reasonably be expected to exist. The competent person must be able to recognize where these conditions are expected. Some gases are heavier than air and can accumulate at the bottom of the trench. For example, hydrogen sulfide, carbon dioxide, and vapors from fuels are heavier than air. Other gases like methane and carbon monoxide are lighter than air. This is important to know when sampling. There may also be oxygen deficient situations where purging with an inert gas had occurred, for example, decommissioned gas lanes. Remember, sources may come from outside the trench and creep in or come from inside the trench, that is, gas lines, contaminated soil, gas power tool equipment. Water accumulation. Employees must be properly protected when working in excavations where water has accumulated or in accumulating. Precautions will vary with each situation but may include diversions, dewatering systems, special sporting systems, or water removal equipment. The competent person must monitor water removal equipment. Water is one of the major concerns during excavation operations. The action of water in excavations can cause undermining cave-ins. Water accumulation. Water accumulation is one of the major concerns during excavation operations. Water simply allows dirt to move much easier and quicker than it would normally. Think of digging in the sand on a beach. Capillary effect: standing water wicks up and saturates the trench side walls as it wicks up the earth's natural at rest angle. Think of this wicking effect like a bath towel wrapped over a bathtub with standing water or the wick on the candle. Type C soil provides a shorter wicking effect than more cohesive type A soil with significant amount of clay. Will show you the examples of type C and type A soils. Water, that is rain, can also fill in tensions, surface cracks at the edge of the trench, causing a hydrostatic effect within this tube, leading wedge failure. Where the stability of adjacent buildings, walls, or other structures is endangered by excavation operations, support systems such as shoring, bracing, underpinning must be provided to ensure stability. Excavation below the level of the base or footing that could pose a hazard is not permitted except when the excavation is in stable rock or support system is provided or registered professional engineers approves. Sidewalks, pavements, and appurtenances structures must not be undermined unless a support system or another method of protection is provided to protect employees from stability of adjacent structures. Support systems such as shoring, bracing, underpinnings, retention systems, or other engineering must be provided to ensure stability. Don't forget sidewalks, other pavements. Daily inspections of excavations, adjacent areas, and protective systems must be made by competent persons for evidence of a situation that could result in possible cave-ins. Failure of protective systems, hazardous atmospheres, or other hazardous conditions. What are we inspecting? If evidence of a possible cave-in, failure in the protective system, hazardous atmosphere, or other significant concerns are found, all affected workers must be removed from hazardous exposure until rendered safe. Protection from loose rock or soil. Scale back and maintain at least 2 feet from the edge. Note the image on the right recommends 3 feet. The more you can recess it back, the better. Remember, the height of the spoils is added to the depth of the trench when placed at the edge. The example is shown on the right side in picture. Protection from loose rocks or soil. Scale back to remove loose materials or install protective barricades and place all material and equipment at least 2 feet from the edge. Fall protection. Walkways must be provided when employees or equipments are permitted to cross our excavations. Adequate barriers, physical protection must be provided at all remotely located excavations. All wells, pits, shafts, etc. must be barricades or covered. Backfill as soon as possible. Fall protection. Walkways must be provided where employees or equipments are permitted to cross our excavations. Always consider fall protection for the folks on the side of the trench or excavation and install when feasible and when it does not create a greater hazard, that is railing, barricades, fencing, management control, etc. Protective systems. Employees in excavations must be protected from cave-ins by an adequate protective system except when excavations are made entirely in stable rock or excavations are less than 5 feet deep and a competent person determines there is no indication of potential cave-in. Protective system must have the capacity to resist all load without failure. Stable rock means natural solid mineral material that can be excavated with vertical sides and will remain intact while exposed. Unstable rock is considered to be stable when rock material on the sides or sides of the excavation is secured against cave-in or movement by rock bolts or by another protective system that has been designed by a registered professional engineer. Selection of protective system. Protective systems are divided into two categories: sloping and benching system. Second is support system, shield system, and other protective systems. The use of either of these two categories of protective systems require the choice of one or four design options. Note: protective systems of excavation over 20 feet in depth must be designed by a professional engineer. Protective systems, excavations and trenches less than 5 feet deep must still be sloped, benched, or otherwise supported when a competent person determines there is an indication of cave-in. Be careful not to get caught up on just the 5 foot depth requirements. Consider work practices in a shallow trench as well as that is working hunched over on hands and knees. Here is an example shown in the picture. Selection of protective system. Protective systems are divided into two categories and includes four choices in each. One, sloping and benching system. Second, everything else. The basic system of protecting employees from cave-ins are sloping, benching, shoring, and shielding. The system that you should use depends on the factors such as soil type and water content, excavation depth, and width, the nature of work, the nearby activities that could increase the risk of cave-in. The competent person has the responsibility for considering these factors and for determining the appropriate protective system. A registered professional engineer must design protective systems for all excavations that are more than 20 feet deep. Requirements for protective systems. Sloping and benching options. The four options include sloped or no steeper than 1 into half ratio 1 34 degrees. Maximum allowable slopes and configurations. Designs using the tabulated data or designed by a registered professional engineer. We have few options here, in which option number 1 are allows excavation sloped at an angle no steeper than 1 into half ratio 1 34 degrees. This sloping option must be in accordance with configurations shown for type C soil in sloping and benching. Option 2 allows sloping and configurations in accordance with the condition and requirements Appendix A soil and Appendix B soil and bench. We have different types of soils and maximum allowable slopes for excavation. This is just for reference. Option number 3 allows designs of sloping and benching systems from one tabulated data must identify the parameters affecting the selection of the slopes or bench systems, limitations, and any other necessary explanatory information aiding the user in selecting correctly. Must be kept on the job site during construction of the system. Option number 4 is allows approval from a registered professional engineer must include the same criteria as described above in option number 3. Here are the examples of the soils: type A soil, type B soil, and type C soil. Benched slopes are permitted only in type A and type B soils. Option number 2 allows the use of manufacturer's tabulated data must be in accordance with all manufacturer's specifications, recommendations, and limitations. Deviation can only be approved by manufacturer. Data must be in writing and kept at the job site during construction of protective system. Option number 3 allows the use of other tabulated data must identify the parameters affecting the selections, limitations, and any other necessary explanatory information aiding the user in selecting correctly. Must be kept at the job site during construction of protective system. Option number 4 allows approval from a registered professional engineer. The design must be in writing and kept at the job site during construction of the system. Materials and equipments. Materials and equipment must be used for protective systems must be free from damage or defects that might impair their proper function. Manufactured materials and other equipments used for protective system must be used and maintained in the manner that are consistent with manufacturer's specifications. A competent person shall examine damaged materials or equipment to evaluate its suitability for continued use, installation, and removal. Support system members are to be securely connected to prevent sliding, failing, kickouts, or other predictable failures. Installations should begin at the top and progress of the bottom of the excavation. Removal shall begin at the bottom and progress to the top. Members shall be released slowly so as they note any indication of possible failure of the system or the excavations. Backfilling shall progress together with removal of support system. Trench support. Materials may be dug to a level no more than 2 feet below the bottom. Members of a support system, if this system is designed to resist the forces calculated to the full depth of the trench and there is no indications of the soil loss from behind and below the bottom of the support system. Sloping benching. Employees may not work on the faces of slopes and or benches above other workers unless the workers are at the lower level are protected from the hazard falling, rolling and sliding materials or equipments. Shield systems. Shields shall be installed in a way that will restrict lateral or other hazardous movements of the shield in the event of sudden lateral pressure. Installation should begin at the top of and progress to the bottom of the excavation. Removal shall begin at the bottom and progress to the top. Members shall be released slowly so as to note an indication of possible failure of system or in the excavation. Shield system. Shields shall be installed in a way that will restrict lateral or other hazardous movements of the shield. In the event of sudden lateral pressure, wedge rules judgment call, they must snug or backfill around. Shields are not designed to withstand significant lateral. Be sure the shield is designed to be pulled again. Remain cognitive. Safe rigging practice. Only manufacture shear pins when stacking compatible shields. Workers must be protected from hazards of cave-in when entering the areas protected by shields. Workers must not be allowed in shields when shields are being installed, removed, or moved vertically. Lateral horizontal pressure is approx half of the downward vertical earth's pressure. 500 of lateral pressure near the bottom of this 10 feet deep cubic foot column. The area where most stress occurs is approx 2 by 3 of the depth. Bulging will often begin here. 1000 lbs of natural downward earth pressure. Just like a cut on our arm, a cut made in the earth's surface will eventually heal. All trenches and excavation will eventually cave in, we just don't know when. Here is an example. How long trench walls stand depends primarily on soil type and weight, moisture and organic material. There are already naturally occurring forces attempting to cave in the trench. In addition, other factors are involved to promote the cave-in such as superimposed loads at the edge of the trench, spoil pile excavation equipment, fisheries and tension cracks, vibrations, water and previous disturbed. How hydraulic shoring works. Here is an example. Top view. Lateral forces from both ends. Vertical pressure attempts to knock the top keystone out. However, by design, the top keystone applies pressure to the other and equilibrium is maintained. Hydraulic shoring creates the arching effect and counter pushes back the earth lateral